So here two functions f and g defined from R to R. It is given by f of x is equal to 7x square plus x minus 8 for x is less than or equals to 1. And similarly 4x plus 5 for x lies between 1 and 7. 7 is included, 1 is excluded. And 8x plus 3 where x is greater than 7. And similarly g of x is given mod x for x is less than minus 3 and 0 for x lies between 3 and 2. And for x is greater than 2 it is given x square plus 4. So let us find the composite functions f circle g of negative 3. So we can write f of g of negative 3 and g of negative 3 means the function can be taken here 0. So f of 0 is equal to when x is 0, you can consider x is less than or equals to 1 case. So we can write 7 into 0, 0 square plus 0 minus 8, that is negative 8. So f of 0 is f circle g of minus 3 is negative 8, but it is given in the option 8 is plus 8. So first option is not correct. Coming to the second option, f circle g of 9, which is equal to f of g of 9, and for 9 for x is greater than or equals to 2 we must consider. So we can write f of 9 square plus 4, that is f of 9 square is 81 plus 4 is 85. So f of 85 and f of 85 means we must go with an option x is greater than 7. So 8 times 85 plus 3. So here 640 plus 40, that is 618 plus 3, which is equal to 683. So f circle g of 9 is equal to 683. So we can say that option B is correct. So let us also identify option C and D. So let me explain you how to find out. So f circle g circle f. So g circle f of 0. So we can write g of f of 0 in the f function where x will be 0, that is x less than or equals to 1. So we can write g of f of 0 is 7 into 0 square plus 0 minus 8, that is g of minus 8, and g of negative 8 will be considered in x less than minus 3 case, that is mod x. So we can write mod of negative 8 which is equal to 8, but it is given negative 8, so option C is also wrong. And coming to the option D, so we can say that g circle f of 6 can be considered for 1 x lies between 1 and 7. So we must take g of f of 6 is equal to g of 4 into 6 plus 5. We must consider this 4x plus 5 function. So which implies 6 4s are 24 plus 5 29. Then g of 29 which is greater than or equals to 2. So we can say here 29 square plus 2. So we can write here 29 square is 29 square plus here we can write 4, sorry, this is 4. 781 plus 4, that is 30 square is 900. So it is almost like 841. So we can write 841 plus 4, that is 845. But it is given 427, so which is wrong option. So we can go with an option B. Given f of x is equal to ax plus b upon cx plus d. First of all, this function is defined when cx plus d is not equals to 0, that is x not equals to minus d upon a. And now we need to see the composite function f circle f of x is equal to f of x, that is f of ax plus b upon cx plus d, which is equal to, and again we can write, again applying the composite function here, f of the f of function a into, in place of x we need to substitute ax plus b upon cx plus d. So we can write a into ax plus b upon cx plus d plus b upon c times of ax plus b upon cx plus d plus b On simplifying, we can write a square x plus ab plus b times of cx plus d divided by c times of ax plus b plus b times of cx plus d. The numerator and denominator cx plus d gets cancelled, and on simplification, f circle f of x is equal to a square x plus ab plus bcx plus bd divided by acx plus bc plus bcx plus bd. We can write a square plus bc of x plus ab plus bd divided by ac plus bc of x plus bc plus bd, and this composite function f circle f of x is given as x, so which is equal to x here. So on cross multiplication, a square plus bc of x plus ab plus bd of bd is equal to x times, so that is x square times of ac plus bc plus x times of bc plus cd. To make this equal, or we can write x square of ac plus bc plus x times of bc plus cd. Let us bring here minus a square minus bc, and minus of ab plus bd is equal to 0. So to get this expression equal to 0, or f circle f of x is equal to x, so we must consider here, say bc and bc get cancelled. So coefficient of x square, or coefficient of x square must be equal to 0, that is ac plus bc is equal to 0, that is c times of a plus b is equal to 0, so a is equal to negative b. And similarly coefficient of x here, cd minus a square is equal to 0. And the next case, constant term ab plus bd also must be equals to 0, that is a plus d equals to 0 by taking b common, so a is equal to negative d. So if these conditions are satisfied, we can say that this composite function f circle f of x is x. So among the options, we can say when a is not, a is equal to negative d, or d is equal to negative a, so which is option A. Option A is the right answer. Given function f of x is equal to x when x is a rational number, and 1 minus x when x is an irrational number, and we need to find the composite function f circle f of x. So consider f circle f of x, which is equal to f of x, which is equal to, we can write f of x whenever f of x is a rational number, and whenever f of x is an irrational number, so we can write 1 minus f of x according to the definition given. Now our f of x will become x when x is a rational number. We can say f of x is equal to x, and whenever x is irrational number, so we can write 1 minus f of x can be taken as 1 minus x. So in both the case, you are getting 1 minus of 1 minus x is nothing but x. So whether x is a rational number or x is an irrational number, you are getting x. So which implies f of x, that is composite function f circle f of x, is equal to x. So we can go with an option B. Given function f of x is equal to 1 minus x upon 1 plus x, and here this function is defined for x is not equals to minus 1. Now we need to find the domain of the f inverse function. So let us consider f of x is equal to y, which implies 1 minus x upon 1 plus x is equal to y. The cross multiplication 1 minus x is equal to y times of 1 plus x. Further implies 1 minus x is equal to y plus xy. So we can write 1 minus y is equal to xy plus x. So 1 minus y is equal to x taken common y plus 1. So we can write x is equal to 1 minus y upon 1 plus y. So basically a function defined from a to b. So the image of x can be taken as f of x here, or we can take y. And in the case of inverse function, when this is bijective, and here f of x, that is y, will come as f inverse of y. F inverse of y is equal to x. So we can write x is equal to f inverse of y. F inverse of y is equal to 1 minus y upon 1 plus y, and f inverse of x is equal to 1 minus x upon 1 plus x. So here the denominator 1 plus x cannot be equals to 0, that is x is not equals to minus 1. Therefore the domain of inverse function f inverse function is given by r minus minus 1. So we can go with an option B. If f is an even function and g is an odd function, then the function f circle g is given. So first let us see even function and odd function definition. If f of negative x, if f of negative x is equal to f of x, we can consider the function as even function. And if f of negative x is equal to negative of f of x, then we can consider as odd function. So here we need to identify f circle g function. Let us consider f circle g of negative x, which is equal to f of g of negative x, and it is given g is an odd function. So g of negative x is equal to minus g of x. So we can write f of minus g of x, and f is an even function, that is f of negative x is equal to f of x. So we can write f of g of x. F of g of x is nothing but f circle g of x. So we consider f circle g of negative x is equal to f circle g of negative x is equal to f circle g of x, which is even function. So we can say the composite function f circle g is an even function. We can go with an option A, even function. If f of x is equal to x upon under root of 1 plus x square, we need to find f circle f of x. So let us consider f circle f of x, which is equal to f of x, which is equal to f of x upon root of 1 plus x square. Now we need to replace in place of x upon root of 1 plus x square. So we can write x upon root of 1 plus x square divided by under root of 1 plus x upon root of 1 plus x square whole square. So we get f circle f of x is equal to x upon root of 1 plus x square divided by under root of 1 plus x square plus x square upon 1 plus x square, which is equal to x upon root of 1 plus x square into under root of 1 plus x square divided by under root of 1 plus 2x square. So we may cancel root of 1 plus x square. So f circle f of x is equal to x upon root of 1 plus 2x square. Now we shall consider f circle f of x, which is equal to f of f circle f of x, which is equal to f of x upon under root of 1 plus 2x square. So let us simplify this. So we can write x upon root of 1 plus 2x square divided by under root of 1 plus x square divided by 1 plus 2x square, which is equal to x upon root of 1 plus 2x square into under root of 1 plus 2x square divided by 1 under root of 1 plus 2x square plus x square, that is 1 plus 3x square. So we may cancel here 1 plus 2x square under root. So we are getting x upon under root of 1 plus 3x square. So which is option B. X upon root of 1 plus 3x square is answer B. If f is a function from R to R, from real numbers to real numbers, defined by f of x is equal to 2x plus 3. 2x plus 3 is a linear function, and since the domain and codomain both are real numbers, we can consider that this function is bijective, which is both 1 1 and on 2. And hence we can say inverse of the function exists. So let us assume that f of x is equal to y, that is 2x plus 3 is equal to y. So 2x is equal to y minus 3. So we can write x is equal to y minus 3 upon 2. And if we see the mappings, f is a function from R to R. Say this is A to B. Consider the domain x and the image is y, which is equal to f of x. Now if we take the inverse, when f inverse exists, means when f inverse is a function, so b to a, so here y it comes as x, so which is nothing but f inverse of its image of y with respect to f inverse function. So we can remember x is equal to f inverse of y. So we can write here f inverse of y is equal to y minus 3 upon 2. So changing the letter, f inverse of x is equal to x minus 3 upon 2. So we can go with an option x minus 3 upon 2 is option A. Given function f of x is equal to root 3 sin x minus cos x plus 2, and we need to find the inverse of this function when f is defined from minus pi by 3 comma 2 pi by 3 to 0 to 4. Let us simplify this function. We can write f of x is equal to multiplying and dividing with 2. So we can write root 3 by 2 into sin x minus 1 by 2 into cos x plus 2. So 2 times. So we can write here sin x and root 3 by 2 is cos pi by 6, and again cos x, and 1 by 2 we can write sin pi by 6 plus 2, that is 2 times of, it is in the form sin a cos b minus cos a sin b, which is equal to sin of a minus b. So we can write sin of x minus pi by 6 plus 2, and we know that the sign range lies between 0 minus 1 to 1, and it is plus 2, so your range will be 0 to 4 and even within the domain. So we can consider that this function is we can consider this function f is bijective and f inverse exists. So let f of x is equal to y, that is 2 times of sine of x minus pi by 6 plus 2 is equal to y. So 2 sine of x minus pi by 6 is equal to y minus 2, or sine of x minus pi by 6 is equal to y minus 2 upon 2, or x minus pi by 6 is equal to sine inverse of y minus 2 upon 2, or we can write x is equal to sine inverse of y minus 2 upon 2 plus pi by 6. So basically x is nothing but when f of x is equal to y, then x is equal to f inverse of y. So we can write f inverse of y is equal to sine inverse of y minus 2 upon 2 plus pi by 6. So changing the variable, f inverse of x is equal to sine inverse of x minus 2 upon 2 plus pi by 6, which is option B. So we can go with an option B. Given function f of x is equal to negative x square plus 6x minus 8, which is bijective. Bijective function, which implies that f is both 1, 1 and onto. So we can say onto function. When the function f is onto, we can conclude that the range of the function f is equal to codomain of the function. So which is given here b. So to find the value of b, we need to find the range of f. So let us find the range of the function. Let y is equal to negative x square plus 6x minus 8. So that we can write x square minus 6x plus 8 plus y is equal to 0. So it's a quadratic equation since x is a real number, because the domain is all real numbers. So discriminant must be greater than or equals to 0. That is b square minus 4ac must be greater than or equals to 0 when comparing with ax square plus bx plus c equals to 0. So we have a is equal to 1, b is equal to negative 6 and c is equal to 8 plus y. So let us write the condition. B square, that is minus 6 whole square, minus 4 times of 1 into 8 plus y is greater than or equals to 0, that is 36 minus 4 times of 8 plus y is greater than or equals to 0, or we can also take 36 is greater than or equals to 4 times of 8 plus y, or 9 is greater than or equals to 8 plus y, or we can also say 8 plus y is less than or equals to 9. So y is less than or equals to 9 minus 8, that is 1. So we can consider that y belongs to minus infinity to 1. So therefore the range of the function which is nothing but b is nothing but minus infinity to 1. So which is option minus infinity is open interval because it's not a number. So we can go with an option B. Given that a set E is equal to 1, 2, 3, 4, that is number of elements in the set E is 4, and set F is equal to 1, 2, that's number of elements in set F is equal to 2 elements are there, and we need to find the number of onto functions from E to F. We have that if F is a function defined from A to B containing the number of elements in A is n and number of elements in B is m, then we have number of onto functions if m is equal to 2 is given by is given by 2 to the power of n minus 2. So here n is equal to 4. So the number of elements in the first set. So n is equal to 4. And here we can see that m is equal to 2. So whenever m is equal to 2, so total number of elements in set B is 2. Then we can use the formula that number of onto functions which is equal to 2 to the power n minus 2, that is 2 power 4 minus 2, that is 16 minus 2, 14. So we can go with an option A. A function f from R to R defined by f of x is equal to x minus m upon x minus n, where m is not equals to n. We need to check whether this function is one-to-one or onto. We know that condition for one-to-one, f of x is equal to f of y implies x is equal to y. This is the condition for one-to-one. So let us consider f of x, that is x minus m upon x minus n is equal to f of y, that is y minus m upon y minus n. The cross multiplication x minus m into y minus n is equal to y minus m into x minus n. So xy minus my minus nx plus mn is equal to xy minus mx minus ny plus mn. On simplifying, mn gets cancelled on the same both the sides, and here we can write xy, and xy also gets cancelled here. So we can write here mx minus nx, and then ny minus my is equal to 0, or x taken common here m minus n, and here minus y taken common. So we can write m minus n again is equal to 0. So m minus n of x minus y is equal to 0. So which implies x minus y is equal to 0, that is x is equal to y. So for f of x is equal to f of y, we are getting x is equal to y, and hence we can conclude that f is one-to-one. Now to check for onto, let y is equal to x minus m upon x minus n, and onto definition says that for every y belongs to B, there exists at least one x belongs to A such that f of x is equal to y. So this is the definition for onto. So let f of x is equal to y. So on simplifying, y times of x minus n is equal to x minus m, or xy minus nx is equal to x minus m, or we can also write x plus nx is equal to we can write here x minus x plus nx minus ny is equal to m, that is x taken common. So here we can write x times of 1 plus n. Let's take the x terms together. X plus nx minus xy is equal to m, or we can take common 1 plus n minus y is equal to m. So we can write x is equal to m upon 1 plus n minus y. Sorry, here this is ny. So xy minus ny is equal to x minus m, or we can write x minus xy is equal to m minus ny, or we can take x common, 1 minus y is equal to m minus ny. So x is equal to m minus ny upon 1 minus y. So clearly we can say that here for y is equal to 1, x is not defined. Means this x is a real number. Since it is given x is a real number, so for y is equal to 1 and codomain is also real numbers. So for y is equal to 1, we can say x is not defined. And hence there is at least one value of in the real numbers 1 for which the function is not defined, for which there is no value of x such that the function is defined, and hence we can conclude that this is not onto. So f is not onto. So when f is not onto, we can call it as an into function. So the function f is 1 to 1 and into. 1 to 1 and into function is option B.